So you will be reading about some new types of geometries, some non-Euclidean geometries. And in this video, we're just going to do some worked examples related to those reading assignments. So in the first example, a triangle sits on a sphere with radius 2. So the sphere has radius 2, and each interior angle of the sphere measures 120 degrees. Find the area enclosed in the spherical triangle. So for these types of questions, so imagine that you have a sphere. Okay, then on the sphere sits a triangle, and the angles of the triangle are all each 120 degrees. So we just want to see how much area sits inside this spherical triangle. The formula for that is given by, the area is given by the sum of the angles. Okay, if A, B, and C are the angles of the spherical triangle. And we subtract 180 degrees, multiply by pi over 180 degrees, and then we multiply by r squared. So in this case, we have 120 degrees plus 120 degrees plus 120 degrees minus 180 degrees times pi over 180 degrees times r squared. So in that case, that's 2 squared. And simplifying this gives me 360 degrees minus 180 degrees times pi over 180 degrees times 4. So this is 180 degrees times pi over 180 degrees times 4, and that leaves me with 4 pi. And if we wanted to express that as a decimal and round to the, let's say, nearest hundredth place, so let's say I wanted to round to this place, I see that there's a 6 here, so this is approximately 12.57 square units. So in this example, we are being asked to find the city distance and the Euclidean distance between the points -1, 5 and 2, 4. So both of these geometries exist in the flat plane, but distance is measured in a different way. And so we're going to first calculate the city distance. And the city distance is given by the formula. So we're going to take the difference of the x coordinates of our points, and then we're going to add that to the distance between the y coordinates. So this point, we're going to give the notation x1, y1. And the point Q, we're going to call x2, y2. So using the formula, we have 2 x2 minus x1, so 2 minus -1, plus distance between y2, which is 4, and y1, which is 5, and this gives the absolute value of 3 plus the absolute value of -1, so that's just 3 plus 1, which is 4. So what exactly does that mean? How do we interpret that? Well, the city distance is measured by moving along city blocks. So imagine you're in the city and you can only travel along streets. So the streets run north-south, and they also run east-west. Okay, so you can only travel, you can't like cut across one of the squares. You just have to travel east, west, or north, south. So that is how city distance is measured. Okay, and in this case, so what we've basically done here is we've just moved along 3 blocks going east, and then we go 1 block south, and you can see that's a total of 1, 2, 3, 4 blocks. Now let's calculate the Euclidean distance, and we'll use the formula d with the little e. And Euclidean distance is given by the difference of the x coordinates of the point squared plus the difference of the y coordinates squared, and we take the square root. So in this case, x2, we have 2 minus x1, which is -1, and we square that. And then we take y2, which is 4, and we subtract y1, which is 5, and we square that. So we have the square root of 3 squared plus negative 1 squared. So this is the square root of 9 plus 1, which is the square root of 10, which is equal to 3.1622, which if we round to the 10th place, that is 3.2 units. And if you want to understand what Euclidean distance means, it's just the length of the shortest line segment between these points. And you can connect this to the Pythagorean theorem because this is actually the hypotenuse of the following triangle, where one leg is given by the difference in the y coordinates, which we saw was 1, and then the other leg of the right triangle is given by the difference between the x coordinates, which we found to be 3. So that's all we're really doing here. This is just the Pythagorean theorem that gives us the Euclidean distance. Okay, the last thing I want to do for you is sketch the city circle with radius 3 and center 4, 2. So the first thing I'm going to do, I'm just going to draw the center. 1, 2, 3, 4. And so here's the center of my city circle. And remember that a circle is formed, it is the collection of all points that are a distance 3 from the center. So, but in this case, we're going to use city geometry, so we're going to use city distance. So if this had been Euclidean geometry, I would have drawn, I would have drawn like a circle that looks like a regular circle, the set of all points. However, it's not Euclidean geometry, so we're not going to have like a regular looking circle. We're going to use city geometry and city distance. So remember, in city distance, we have to travel along the blocks in the city. So northwest, southeast. This point here is a distance of 3 from my center, and so is going out this direction. I have 1, 2, 3. So is this point, and I have 1, 2, 3. This is also 1, 2, 3. So these points are going to be on my city circle. So if I start at the center and I go out 1, 2, 3, this point will be on the city circle. Again, if I start at the center, I go 1, 2, 3. This point will be on the city circle. I can go down here, 1, 2, 3. This is on my city circle. 1, 2, 3. That's a distance of 3. And then if I go out 1, 2, 3, this point is on the city circle. 1, 2, 3, etc. And you can sort of see now the shape, how I form the city circle. So the following 12 points are make up my city circle.